And the next rule to go over is called the chain rule. And the chain rule applies to a situation like this. Suppose we have a setup like this. Suppose let z be some function of y. Okay. Which means for each value of y, there's a unique value of z. And let's also let y be some function of x. So let y be g of x. So what this means is for each value of x, there's a unique value of y. And for each value of y, there's a unique value of z. So what that means is for each value of x, there's also going to be a unique value of z. So really, z can be expressed as a function of x. Okay. And in this type of setup, if you could take the derivative of z with respect to x using the chain rule. And the chain rule is very simple to remember. It's just dz dy. Notice z is a function of y, so we assume you find its derivative, dz dy. And then you multiply that times dy dx. And notice you could think of those dy's as canceling. So then you would just have the left-hand side and the right-hand side would be the same. If you think of these dy's as canceling out each other, then the left and right-hand side would be the same. All right, let me show you a case where this rule will actually help you find the derivative. The most common example is a case like this. Suppose z is equal to 10 plus 2x raised to the 5th power. And really what you want is the derivative of z with respect to x. Well, with what you know right now, the way to do it would be to multiply 10 plus 2x times itself 5 times. Then you'd get some ugly looking expression and then differentiate that with respect to x. However, there is a slicker way to do it. And the slicker way to do it is to use the chain rule. Okay. And now let's let y, let's introduce a new variable. Let's let y equal 10 plus 2x. Then by introducing this new variable y, we could say z is equal to y to the 5th. And notice z is a function of y. Z is equal to y to the 5th. Y in turn is a function of x. So then we can use the chain rule. And using the chain rule, we can get the derivative as follows. dz dx is equal to dz dy. And what is dz dy? Let me write this again. dz dy times dy dx. Now, what is dz dy? Anybody? Diana? It's just 5 times y to the 4th. Okay, that is dz dy. We just take this expression right here. What is dy dx? dy dx is just 2. So dz dx is just equal to 10 y to the 4th. And usually you want to express this in terms of x. So now you just substitute in y is equal to 10 plus 2x. So the answer is 10 times y, which is 10 plus 2x, all raised to the 4th power. This is much quicker than multiplying 10 plus 2x times itself 5 times and then differentiating. Okay. But for those of you who want to check the veracity of the chain rule, you could do that and you would end up with the same answer. Okay. Now, actually, when I do this type of differentiation, I don't actually go through all these steps. There's a shorthand method you could use to do this kind of differentiation. Did any of you remember how you do this differentiation straight away without going through all these steps? Does anybody know straight off how to differentiate this? Okay, Ben, go ahead. All right, so we'll say dz dx is equal to, bring that 5 down, times 10 plus 2x, then what? 4th, and then what? Exactly, yes. The way I remember this is the derivative of the outside times the derivative of the inside. The derivative of the outside is this part that Ben just mentioned. Now, the derivative of the inside with respect to x is just 2. And then you get 10 times 10 plus 2x to the 4th. Okay. All right. So that is the chain rule.